morning students. In the previous class, you see the integration is of the form e power ax into sin bx or e power ax into cos bx. Now we move the next exercise. Now in this exercise, the integration is of the form. This also is a special case. In integration, one term is e power x, and within a bracket, one is f of x, where f of x is a function. It may be in terms of x or y, like this. Suppose it is in terms of y, we write it is f of x. So f of x is a one function, it's not a constant, one function. And another one is f dash of x. Now what is the difference between f of x and f dash of x? The differentiating of f of x with respect to x one time is nothing but f dash of x. Now we are integrating. So with respect to x. Suppose the integration is of the form e power x is lies outside. Within this bracket, actually one is the differentiating of the other. Suppose the integration is of the form whose integration value is e power x into f of x plus c. Now we see the next exercise fully involving these formulas. So the new type of one integration, but also is nothing but a formula or a concept. So integration of e power x f of x plus f dash of x, whose integration value is this e power x into f of x. I give one example. Suppose in integration it is e power x. Within a bracket I write sin x plus cos x into dx. Now I say this sum is of the form that model. You identify there is a relation between these two terms. The differentiating of one term is nothing but the other term. The differentiating of a sin x is nothing but cos x. So we consider it is f of x. And the differentiating of sin x is cos x, so we consider it is f dash of x. So exactly the differentiating of one term is nothing but the other term. So the formula is e power x. So we write e power x into f of x. Here what is the value of f of x? Sin x. So e power x into sin x plus c. So in the next exercise we see fully involving this kind of problems. In one or two sums directly given the shape. In other problem, indirectly given the term, we simplify the sum of these two terms, then the shape will come then using this formula. So the formula is in integration e power x into f of x plus f dash of x into dx, whose formula is e power x into f of x. What is the difference between f of x and f dash of x? One time differentiating of f of x with respect to x is nothing but f dash of x. In exercise 11.9, we see the problem, we see the question. The integrate the following with respect to x. So it is a first sum e power x within a bracket tan x plus log secant x. So using this formula, the word is not given. You must understand the sum is follows the previous formula. Okay, now we see the sum. Now we integrate the term with respect to x. So integrating of e power x of first term is tan x plus the next term is log secant x. We are integrating, so with respect to x, so we put dx. Okay. I write elaborate. In this bracket term, one is a differentiating of the other, directly given. You see, one term is a differentiating of other. I say the differentiating of the second one is nothing but the first one. How it is possible, sir? The differentiating of a tan x is a secant square x, but it is not a secant square x. But the differentiating of log secant x is nothing but tan x. So one term is a differentiating of other. So now we come in formula method. Now in each and every sum we must write a formula. What is the formula? E power x into f of x plus f dash of x into dx, whose formula is e power x into f of x. Okay. Here we will be take the value of f of x. It's important. We will be taking which value is f of x. Actually, f dash of x is the differentiating of f of x. So two terms is there. So one is tan x and another one is log secant x. The differentiating of tan x, you know the formula is secant square x. So that second term is not a secant square x. So if we take the value of f of x is a log secant x. Log secant x. The next step is f dash of x. F dash of x means the differentiating of f of x with respect to x. Now we need the differentiating of a log secant x. Differentiation concept. You know the idea of differentiation? It is a composite function. Log, one variable is there. First of all, log x differentiation is 1 by x. So log secant x differentiation is 1 by secant x. Okay. But it is composite function. Again, secant x is there. The differentiating of a secant x is a secant x tan x. Now we cancel this secant x. Secant x is cancelled. So f dash of x is exactly tan x. Okay? So exactly the differentiating of one term is nothing but the other term. So we write therefore integration of e power I x tan x, or we write it is log secant x. Is our choice. We write any manner plus tan x into dx is equal to. Now I write exactly the form e power x of f of x plus f dash of x into dx. So our formula is e power x into f of x. Here the f of x value is log secant x. So log secant x plus c. It is our answer. But in every log, the neighbor term lies within modulus. Or we write it is e power x log modulus secant x plus c. So it's also your answer. So it is very important to identify which value is f of x. So another one is f dash of x. So finding the term of f of x is very important in this model. Now we see the second one. E power x within a bracket x minus 1 divided by 2x square. Now we solve the problem. Integrating of e power x minus 1 by 2x square into dx. It is not the directed sums. So actually only one term is given. Now we split because one term differentiation is nothing but the other one. First of all, x is only 1, 2 is there. You know very well in integration, suppose a constant lies inside, you will be take outside. So I will take this 2 first of all outside. But the number 2 lies within denominator, so 1 by 2 of e power x. X minus 1, we already take outside 2, so remaining is just x square. 1 by 2 e power x of, now actually it is a single term. Now I split the single term into the double term. This x square is common in both. So we split, we get x by x square. Okay? Minus sign is there. Minus 1 by x square into dx. Now I cancel 1 x. So what is remaining? 1 divided by x square, 1 x is cancelled, remaining is x. So the term is 1 by x. So 1 by 2 of outside 1 by 2 in integration e power x of 1 by x minus 1 by x square into dx. Now exactly it is of the form. The differentiating of 1 is other. The differentiating of exactly 1 by x is a minus 1 by x square. So you must write the formula. What is the formula? Integrating of e power x f of x plus f dash of x into dx. The formula is e power x f of x plus c. Here the value of f of x is, which term is f of x is must. Two term is the, which term of f of x identification is a very must. Here the value of f of x is 1 by x. The differentiating of 1 by x is minus 1 by x square. We write directly. For how it is possible, sir? For your understanding, I write. We write 1 by x as x inverse. Okay. The denominator term suppose comes in numerator, there will be a sign change in the power. So x power minus 1. Now we are differentiating x inverse with respect to x. So f dash of x. That means differentiating of f of x with respect to x. X power n formula of differentiation. X power n formula of differentiation is n x power n minus 1. Here the value of n is minus 1. So minus 1 x power minus 1 minus 1. N x power n minus 1. Minus, actually minus 1 into x is nothing but minus x, or we write it is minus 1. We write alone n x power n minus 1 minus x power minus 2. Minus 1 into x is nothing but minus x. So f dash of x value is minus 1 by x square, I write. Okay, the minus sign. X power minus 2 term suppose comes in denominator, it become x square. Now you see exactly minus 1 x square is the next term. So one term is f of x and another term is f dash of x. So whose integration value is e power x into f of x. But important, this integration outside the constant is there. You don't remember the outside the constant. Now I directly write the answer 1 by 2. Okay, I write outside 1 by 2. Now it is on the form integrating of e power x into f of x plus f dash of x into dx. Whose formula is e power x into f of x. So e power x and f of x is here 1 by x. So e power x into 1 by x. Usually we add the constant c. So we write it is numerator 1 into e power x is e power x. Denominator 1 2 1 x is there. 2 into x is 2x. 2x plus c. So in this sum directly the formula is not involved. So we do just the single term become a double term. Exactly the differentiating of one term become the another term. So it is of the form e power x into f of x. Now you see the next one. E power x into secant x within a bracket 1 plus tan x into dx. Integrating of e power x secant x 1 plus tan x into dx. You see outside is just e power x only needed. But this e power x is multiple with secant x within some bracket. Now we already see two sums. You have any idea? Outside is just e power x term only needed. So the remaining term is multiplied inside. Okay. So integrating of e power x. I multiplied secant x inside. So secant x into 1 is secant x plus secant x into tan x. Now we come to the conclusion. Here we see in both the term exactly the differentiating of one is other. Okay, do you identify? The differentiating of this term is exactly that term because the differentiating of secant x is secant x tan x. So it is of the form. Okay, so we write the formula e power x f of x plus f dash of x into dx. So you must write each and every sum formula because only one sum will be asked in your test. So you just write the formula is equal to e power x into f of x plus c. Now we identify which term is f of x. In these two terms, which term is f of x? Actually, the first term is f of x because the differentiating of this one is nothing but that second term. So f of x is secant x The next step is f dash of x. I already tell f dash of x means differentiating of f of x. The differentiating of f of x is f dash of x, and the differentiating of secant x is secant x tan x. So we directly write the answer. So the given one answer is e power x. Okay, and f of x, here what is the value of f of x? Secant x. So e power x into secant x plus c. So the answer is e power x secant x plus c. So simplification of the given sum is very important, and identification of f of x is very must, because the differentiating of one term is exactly will come, the other term is nothing but f dash of x. So in these terms, the identification of f of x is very must. Now we move the fourth one. See, outside is e power x within the bracket 2 plus sin 2x divided by 1 plus cos 2x. Now we solve the problem. E power x of 2 plus sin 2x divided by 1 plus cos 2x into dx. So now the first step is to convert the given sum is of the form e power f of x plus f dash of x into dx. You see, the numerator is 2 term and denominator is also here 2 term. Now we solve the given problem fully involving the formula of trigonometry. Okay, so 1 plus cos x, I write the formula 1 plus cos 2 theta. In trigonometry, exactly the formula of 1 plus cos 2 theta is 2 cos square theta. Actually, the formula of cos 2 theta is 2 cos square theta minus 1. So the minus 1 becomes that side plus 1. So 1 plus cos 2 theta formula is 2 cos square theta. So the sum of 2 term become a single term is the first step, because we need a 2 separate term. So because please suppose the denominator is the sum of 2 term. So the sum of 2 term become a single term using the trigonometric identities. So integrating of e power x 2 plus sin 2x divided by 1 plus cos 2x. 1 plus cos 2 theta is 2 cos square theta. So 1 plus cos 2x is 2 cos square x into dx. Now you have any idea? Numerator is the sum of 2 terms, denominator is a single term. So we split into 2 terms. Suppose we split, you see that there is a chance to cancel this 2. Now is possible to cancel this 2? Impossible, because numerator is sum of 2 terms and also 2 is not common. So the next step is the single term become a double term. So e power x we split. So 2 divided by 2 cos square x plus sin 2x divided by 2 cos square x. Sin 2x divided by 2 cos square x into dx. In the first term, I cancel this 2. Numerator denominator 2 I will cancel. So 1 by cos square x. In second term, you see sin 2x divided by 2 cos square x. Here also, depending upon this 2 term, become one idea. The same trigonometric formula. 2 cos square x is there, and the numerator is sin 2x. Suppose we use any one of the formula, there is a chance to cancel some sin and cos. Often we use the formula of sin 2 theta. In trigonometry, the formula of sin 2 theta is 2 sin theta cos theta. So sin 2x formula is 2 sin x cos x. You remember the formula? The formula of sin 2x is 2 sin x cos x. Divided by the denominator is the same, 2 cos square x into dx. What is the reason to use this formula here? You see, 1, 2 to cancel. Cos x, cos square x, 1 cos is also cancelled. So that's why we use again the formula of sin 2x using trigonometric identities. E power x. You know, 1 by cos is nothing but secant. So 1 by cos square x is secant square x. Plus. In the second term, which term is cancelled? 2. Cos, in cos square, 1 cos is cancelled. What is the remaining numerator? Sin x. By denominator, in cos square, 1 cos is cancelled. Remaining, 1 cos is there. So cos x into dx. E power x of secant square x. We know sin by cos is tan into dx. For your understanding purpose, I change the terms secant square x plus tan x as tan x plus secant square x into dx. Now you identify exactly the differentiating of one term is the other term. The differentiating of a tan x is secant square x. So we converted into the formula sheet. So the given sum is not directly the term. One more term is there. So using some trigonometric identities, we split into 2 terms, and also it is exactly the differentiating of one is nothing but the other. Now it is of the form e power x of f of x plus f dash of x into dx is equal to e power x into f of x plus c. Here what is the value of f of x? Here the value of f of x is tan x. Directly we write the answer of f dash of x. Okay, f dash of x means the differentiating of f of x. The differentiating of a tan x is secant square x. So I directly write the answer. So it is of the form e power x f of x plus f dash of x. So this formula is e power x into f of x. Here what is the value of f of x? Tan x. So e power x into tan x plus c. So this type of sum is also given. Suppose some creative problem is also given. So suppose you very well know the trigonometric identities, then we solve the problem. So the answer is e power x into f of x plus c. Now I move the sixth one. You see the numerator is log x. On denominator is 1 plus log x the whole square. Log x by 1 plus log x the whole square into dx. Now we say all the sums are involving some e power x, but you see there is no e term is given. Okay, so I say your choice, we do any manner, but I solve this problem in this manner. First of all, I do one work. You say I do in which work. What is the difference between these two terms? In numerator log x, I add and subtract 1. Suppose we cancel plus 1 minus 1, then directly log x. What is the reason, sir? Why exactly you add and subtract 1? You see the denominator, this log x is added by 1. So that's why for the simplification process, I will be add 1 and subtract 1 to the numerator. Next, actually the numerator is 3 times, 1, 2, 3. But the denominator is 1 plus log x. So in this purpose, I split first of all. 1 plus log x, I consider as a single term. Minus 1 is a odd term. I consider the sum of two terms become a single term. Minus 1 is odd term divided by 1 plus log x the whole square into dx. Next, you have any idea? So the denominator is 1 plus log x the whole square, and numerator is this 2 terms. Suppose we split in 2 terms. 1 plus log x term will be cancelled, there is a chance. So I split the single term become a double term. So 1 plus log x by 1 plus log x the whole square minus, the sign is the minus, 1 divided by 1 plus log x the whole square into dx. Any term is cancelled a chance. You see the first one, 1 plus log x in whole square, one term fully cancelled. So in integration, what is the remaining first term? Numerator fully cancelled. So 1 by 1 plus log x. What is the second term? Minus 1 by 1 plus log x the whole square. Into dx. You see one term is 1 by 1 plus log x and another term is 1 by 1 plus log x the whole square. But also you see that term e power x is not involved here. Okay. Now we integrate. Directly there is no formula because the two term. And also the term 1 plus log x and another one is 1 plus log x the whole square. So we do any process. For our easy purpose, these two terms become a single term. Now I solve this problem by method of substitution or change the variable. We already tell the rule, method of substitution and change the variable. Now I change the variable because directly there is no formula of this integration. Is your choice will be take any variable. I will take u. The value of u is 1 plus log x. The value of u is 1 plus log x. That is, the sum of these two terms become a single term, u. So now to change all the given variable into the another variable, u. The next step. du. We already tell what is the difference between u and du. Du means taking differential only. So the differential of u is du. Here, 1. The differential of the 1 constant, 0. Plus. First of all, the differential of log x is 1 by x. But it's not with respect to any variable. So the differential of log x is 1 by x. Again, the differential of x is dx. So dx. So we leave this 0. So du is equal to actually dx by x. So the denominator x becomes that side numerator. So x du is equal to dx. So now we see the given sum. So integrating of 1 divided by the term fully u, 1 by u, minus 1 divided by the term fully u square. Okay. Next dx. The value of dx is x du. But we change all the given variable into the another variable u. So this x is also does not include. The value of x is also lies in terms of u. That is dx is equal to x du. Now we change the value of x also in terms of u. In this purpose, again I will take the value of u. What is the value of u? 1 plus log x. Now we need alone the value of x. Okay? So in this purpose, I do one process. What is the name of the process? U value is 1 plus log x. Next, I do one process. The name of the process is rising to the power e on both sides. Because we need only the value of x alone. In this purpose, I will take the rising to the power e on both sides. So e power u. E power 1 plus log x is there. So I write it is e power 1 into e power log x. Okay? When the base is same, we add the power. You know this concept. So I split this 1 e power 1 plus cos x as e power 1 into e power log x. E power 1 is nothing but e is a constant. What is the value of e power log x? E power log x. In differentiation, we already tell the formula of e power log x is just x. E power log x is x. E power log y is y. So e power log, the neighbor term will lies as it is. So e power log x is just x. So here e power u. We need to alone the value of x. So the denominator, numerator e becomes that side denominator. So e power u divided by e is equal to x. That is, the value of x is e power u into e. Now I substitute the value of x in the first equation. Okay, now you see x also in terms of u in first equation. So dx is equal to x. The value of x is e power u divided by e into d. Now we substitute all the value to the given sums. Okay, now we write all the given term into the given sums. Now we come this step. Integrating of 1 divided by 1 plus log x. 1 plus log x is nothing but u. Okay, we write all the term. So integrating of 1 divided by u. Okay, 1 divided by u minus 1 divided by again u square. Wow. Next is dx. The value of dx, you see the value of dx is e power u by e into du. Now if we take the denominator e, suppose the term e only lies, it is a constant. So if we take outside e, 1 by e power u. First I write e power u. 1 by u minus 1 by u square into du. And we take outside the constant 1 by e. Remaining is, first I write e power u, and the remaining terms are 1 by u minus 1 by u square. So in the given sum, the word e power is not given, but do some process is exactly is of the form. We already write elaborately all the sums. Now you see outside is e power u. Inside is 1 by u minus 1 by u square. Already we see this kind of problems. Exactly the differentiating of 1 by u is nothing but minus 1 by u square. So one is f of x and another one is f dash of x. So the integration is of the form e power x into f of x, but here all the terms are involving u. Now we write the formula. Integrating of e power x f of x plus f dash of x into dx is equal to e power x into f of x plus c. It is a formula. But here fully involving u, so I will take it is f of u. So actually we write the formula. But it has given some fully involving u, so I will take it is f of u is 1 by u. What about f dash of u? Minus 1 by u square. We already tell how to find that value. So f dash of u is minus 1 by u square. So directly I substitute the value in the formula, but outside is 1 by e. So you don't remember the value of 1 by e. Okay, 1 by e. Now you see the term 1 by e lies there. 1 by e of e power u of 1 by u minus 1 by u square. So we write 1 by e, and within a bracket e power u into f of u value is 1 by u over plus c. So how to write here? E power u, 1 into e power u is e power u divided by e into u plus c. Is our answer? It is not our required answer because all the given variable are involving x. So again we change. The value of u is nothing but 1 plus log x. E power 1 plus log x divided by e of 1 plus log x plus c. Any chance to simplification here? There is a chance. Again I write e power 1 plus log x as e power 1 into e power log x divided by e of 1 plus log x plus c. Okay. What is the reason to split the numerator? 2 term become a product of 2 term. Now I exactly cancel this e. E power 1 is nothing but e. What is the remaining? E power log x by 1 plus log x plus c. We already tell, or it is a formula, e power log x is nothing but just x. So x divided by 1 plus, all term lies within log, so we write it using modulus. So we write it is 1 plus log x or 1 plus log modulus x. So it's your choice. Suppose sir, I write just x divided by 1 plus log x only, sir. No problem, it's also answer. But any time we write within log, so answer is 1 plus log modulus x. I don't write the modulus, sir. I write just log x. No problem, it's also a answer. So in this sum, directly e power term is not given. We do some process, then the formula shape will come. Okay, now we try the same model sum in examples. In exercise I do the problems. The same model sum lies in example also. We must try in our class note.